Hey guys, today's lesson is on section 4.3, writing linear equations in point-slope form. So far, we've learned two other forms to write a linear equation in. The first one we learned about was standard form. The second one we learned about was slope-intercept form, and this is our third and final form to write a linear equation in called point-slope form. There are two things you need to write an equation in point-slope form. That would be a point that the line will pass through on the coordinate plane, and of course, the slope. If you have a point and the slope, point-slope form is the model right below. Y minus y1 equals m times x minus x1. The reason why the y and the x in this model are in red is because when you write an equation in point-slope form, those two variables will literally be y and x. Just like y equals mx plus b, the y and the x you write as y and x. These two y and x's, the y1 and the x1, that's the x and y value that we're going to get from a point or an ordered pair that the line passes through on the coordinate plane. So we will take that ordered pair and substitute the x1 and y1 into point-slope form, and then m still stands for slope, and that's where the slope will go in point-slope form. So let's take just the first two problems are practice writing an equation in point-slope form, and it's usually the easiest form to write our equation in. The first sentence says, write the point-slope form of an equation for a line that passes through -1, 5, so we have a point, and a slope of -3. We have both pieces of information to write an equation in point-slope form, a point, which will be my x1 and y1 values, and the slope, which will be m. So let's go ahead and just copy our point-slope form, y minus y1 equals m times x minus x1. And now let's fill in our information. Remember that first y is y minus y1 is 5, and that's the y value of the ordered pair or the point that they give us. M is -3, m stands for slope. The first x is x minus the x1 or the x value of the ordered pair they give us is -1. The last thing you're going to want to do is just simplify any double signs. For example, when we have the x minus -1, we're going to want to fix that to y minus 5 equals -3. Remember, when you subtract a negative, that's going to change to a plus sign, so times x plus 1. And that will be our equation in point-slope form. We're going to leave it just like that. You're not going to distribute unless the next couple problems below on our notes is going to ask us to convert this to another form. Otherwise, this is our point-slope form. You're just going to put or substitute the point in for the model and then the slope. Let's check out our next one. It says, write the point-slope form of an equation for a line that passes through 6, -2 with a slope of 1. So again, I'm just going to copy our model, y minus y1 equals m times x minus x1. The ordered pair that they give us represents the x1 and y1 value, and then the slope always stands for m, or m always stands for slope. So in our point-slope form equation, we'll have y minus the y1 value is -2 equals the slope is 1 times x minus our x1 value is going to be 6. Again, we're going to want to simplify when there are two signs. So y minus -2, we're going to simplify to y plus 2. We always just want one sign. Equals, and there is something that we could simplify on the right-hand side. Since the slope, or m, is 1, 1 times anything is itself, so we don't necessarily have to write the coefficient 1, like we don't write 1x, so we could just change that to x minus 6. 1 times x minus 6 is just x minus 6, and we could leave our equation just like that for point-slope form. Point-slope form is very easy to write. As you guys could see, we just substitute the right numbers in the right spots and simplify if we have any double signs. What point-slope form is often used for is because it's easy to convert to other forms. So on the second half of our notes here, we're going to take an equation that's already in point-slope form and convert it to either standard form. Let's remember standard form is ax plus by equals c, or slope-intercept form, the last two problems, which is y equals mx plus b. So let's go ahead and convert. The first thing we're going to do always when we're writing something in point-slope form to a different form is we're going to distribute the slope to the inside parentheses. So we have y minus 2 equals 3x minus 3. Now remember, standard form, we always want the x term first, then the y term, then the equal sign, and the term with no variable at the end. Remember, the other rules for standard form, one in particular, is that a cannot be negative, so let's make sure we keep that in mind. So what I'm going to do first is I know the 3x has to be on the left side, so I'm going to subtract it on both sides to get negative 3x plus y minus 2 equals negative 3. And then I know that that negative 2, I'm going to put it on the right side by doing the opposite operation and adding to get negative 3x plus y equals negative 1. Now again, although this looks like it's in standard form because the x term's first, the y term's second, and then the coefficient with no variable is at the end, a, or the coefficient out front, can't be negative. How did we fix that when we were learning about standard form? You're going to divide everything by negative 1, and coincidentally what that does is just changes all the signs, and this will end up being the standard form for the original equation. Again, point-slope form is used because it's very easy to write an equation in point-slope form when you have the point and the slope of the line. And then it's also easy to then convert it to other forms if you need to. Let's go ahead and try the second standard form. Again, the first thing you're always going to do is distribute the slope. Y plus 7 equals negative 1 times x is negative x, and negative 1 times 2 is negative 2. We're going to take pretty much the same steps as the problem above. I know the x needs to go on the left side, so I'm going to add it on both sides. And I also know it's going to be first, so we have x plus y plus 7 equals negative 2. And I know the 7 has to go on the right side, so I'll subtract it from both sides to get x plus y equals negative 9. Since the coefficient out front is just a positive 1, I don't have to fix it in any way. This would be our standard form for the original equation that was in point-slope form. When you're converting to standard form, there are sometimes a couple of steps. The easiest one to convert to is slope-intercept form, and that will end these sections' notes. Remember, slope-intercept form is y equals mx plus b. So once we distribute, we're going to want to solve for y. When we're going from point-slope form to slope-intercept form, there's actually only 2 steps. Again, the first thing you're always going to do is distribute the slope, so it's y minus 2 equals 3 times x is 3x, and 3 times negative 1 is negative 3. The last step, since I want to solve for y, because in slope-intercept form, y is by itself, I'm going to add the 2 to both sides. Notice on the right side, I'm adding it to the -3 because those are like terms, and we will get y equals 3x minus 1. This is our slope-intercept form for our equation. It's in the y equals mx plus b form, where if we were asked what the slope is, we would say it would be 3, and if we were asked what the y-intercept was, we would say it's -1. Let's finish up with our last problem here. Again, we'll always distribute the slope. 1/2 times x we'll write as 1/2 x, and 1/2 times 4 is 2. The last step to solve for y is to move that +3 over to the right. You're always going to do the opposite operation, which would be subtracting. And notice I'm subtracting it from the 2 because those are like terms. We would end up with y equals 1/2 x minus 1. And this equation is in slope-intercept form, or y equals mx plus b form. If we were asked what the slope was, we would say it was 1/2. And if we were asked what the y-intercept was, we would say it's -1. This ends the 3 different ways to write an equation, a linear equation, 3 different forms. On the next page, we just have a model of all 3. The first one we learned about was standard form, ax plus by equals c, rearranging the terms so they're in that order. The second one we learned was slope-intercept form. It tells you 2 things, the slope and the y-intercept of a line. And in order to write an equation in slope-intercept form, you need to know the slope and y-intercept. And lastly, our third one for this lesson was point-slope form. You need a point and a slope to write your equation in point-slope form, m being the slope and the x1, y1 being the point. Please let me know if you guys have any questions, and I'll talk to you guys soon.